All right, in this video we're going to be talking about solving linear equations, but first we need to talk about some important vocabulary. Our first term is equivalent equations, and these are equations that are set equal to each other so that the variable has the same value in each expression. So in our example, since both of these equations are set equal to y, then they're equal to each other. So we have 5x plus 1 is equal to 3x. We would say that these two equations are equivalent equations. Next, we have inverse operations, and these are operations that undo each other or an operation that undoes another operation. So examples of that would be addition that undoes subtraction. Likewise, subtraction will undo addition. Multiplication undoes division, and division will undo multiplication. Next term is isolate, and that is to get a variable alone on one side of the equal sign. So like when we're solving equations, our goal really is to isolate the variable so that we can find its value. So the example that I have here, x minus 17 equals 3. We can add 17 to both sides of this equation, and you'll notice that the 17 is eliminated on the left-hand side, and we get x equals 20, and we say x is now isolated on the left-hand side. And then next we have a solution of an equation, and that's a value or values you can put in the place of a variable that makes the equation true. So that's kind of the point of solving equations, is to find the solution or the value of the variable that makes it true. So for example, the equation x plus 2 equals 7, x equals 5 is the solution. Since when we substitute 5 in for x, you get 5 plus 2 equals 7, and that makes a true statement, or it makes the equation true. And then lastly, we have what's called a variable, and variables are letters or symbols that are used to represent a value. And in our example, 3x plus 2y equals 18, x and y are considered the variables. Okay, let's take a look at example 1, solving these linear equations. And we have, what is the value of x in this equation? We have 2 times x plus 4 divided by 3 minus 8 equals 32. Well, there's several different ways we can solve this equation. So our first method would be to eliminate the fractions in the equation first. So many times in algebra, we'll come across equations that contain algebraic fractions. And one method would be just to eliminate those to begin with. So you can see that our fraction in this equation has a denominator of 3. So when we're looking to eliminate the fractions, we're trying to look at the denominators and deciding on a number that will eliminate all the fractions in the equation. So since there's only one fraction in this equation, we can multiply everything times 3 in this equation, and that will essentially eliminate the fraction with the denominator of 3. So that's what I'm going to do. I'm going to multiply both sides of this equation times 3. And when I do that, that fraction is eliminated. And 3 times 8 is 24. And 32 times 3 is 96. So you can see with that first step, now I've eliminated the fractions, and now I just have an equation with parentheses and one term here. So then I can go ahead and solve this like I would a normal linear equation. I'm going to use the distributive property to get rid of those parentheses. 2 times x is 2x, and 2 times 4 is 8, minus 24 equals 96. And then here I'm going to put my constants together. And 8 minus 24 is negative 16. So that's 2x minus 16 equals 96. And then I'm going to add 16 to both sides to eliminate the subtracting 16. And that gives me 2x equals 112. And then finally divide by 2 to give me my solution of x equals 56. So that would be the first method in solving this equation. It would be eliminating the fractions first. All right, we're going to take a look at the same equation again, but now we're going to solve it in a different way. We're going to actually just reverse the order of operations to solve this. So the way I like to think about this is I like to start with x and kind of think about what's happening to x in the order of operations. So the first thing that's happening to x is we are adding 4. I have them listed here. And then after we add 4, we multiply that sum by 2. And then after that, we divide by 3. and then after that we subtract 8 to get to our result of 32. So now when we solve this equation, basically what we're going to do is we're going to reverse this order of operations. We're going to undo these with that inverse operations that we talked about earlier. So the first thing that I'm going to do is I'm going to start working backwards. So I'm going to start with the subtract 8, and I'm going to undo the subtract 8, and the inverse operation would be to add 8. So I'm going to add 8 to both sides of this equation, leaving me my fraction, and 32 plus 8 is 40. The next thing I want to undo is the dividing by 3, and to do that, the inverse operation would be to multiply by 3. So I'm going to multiply both sides of this equation times 3. That eliminates this fraction. I'm left with 2 times x plus 4. And 40 times 3 is 120. Next, I want to undo the multiply by 2. And the inverse operation of multiplication is division. So I'm going to divide both sides by 2. And that leaves me x plus 4 on the left-hand side and 60 on the right-hand side. And then finally, the last thing I have to do is undo this addition with subtraction, and that should get me back to x. And I get x equals 56. So you see I get the same solution in either method. So at least you have choices and options, and sometimes one method may be preferred over the other. Okay, I want you to try to solve this equation using both methods. I want you to give both methods a shot and see which one you prefer. So I would pause the video and work through these before you continue watching. Okay, let's solve this equation using method 1, which was eliminating the fractions. And you can see that I only have one algebraic fraction in this equation, and it has a denominator of 2. So I'm going to multiply both sides of this equation times 2 to eliminate that fraction. And 2 times 4 is 8, and 2 times 3x minus 1 over 2 is just 3x minus 1. And 9 times 2 is 18. So here I have some constants that I need to combine, and 8 minus 1 is 7. So I have 7 plus 3x equals 18. I'm going to subtract 7 from both sides, and 3x equals 11. And then one step left, divide both sides by 3, and x equals 11 thirds, or 3 2/3. Now let's look at method 2, which is just reversing the order of operations. So I'm just going to start with x, and I'm going to kind of work my way through the order of operations and just list out what's happening to x in the order that they happen in this equation. So the first thing that happens to x is it is multiplied by 3. The next thing that happens is we subtract 1. Then we divide by 2. And then lastly, we add 4. And that gets us to a result of 9. So what I'm going to do to solve this is work backwards through this order of operations using the inverse operations. So the first thing I want to do is eliminate this add 4 by subtracting 4 from both sides. And on the left-hand side, I'm left with 3x minus 1 divided by 2 equals 5. Next, I'm going to undo the divide by 2 by multiplying both sides by 2. Next, I'm going to undo the subtracting 1 by adding 1. And then finally, I'm going to undo the division, undo the multiplication with division. I'm going to divide both sides by 3. And wouldn't you know it, that leaves me 11 thirds or 3n2/3. So hopefully you were able to solve this equation using both methods, and then it's really a personal opinion on which one you think is best and why.